Right, so today for dilations, to give you a better idea of what dilations are, think back to similar figures where you had either the same picture or the same shape, any image that would be either enlarged or reduced. Those were considered similar figures if the proportions were the same. Now, when you have similar figures, there is a transformation that created the larger image, or from a larger image created a smaller image. And that is called a dilation. So let's write down the definition. A dilation is a transformation which enlarges or reduces a figure. And there's usually a center of dilation. So we'll say with respect to a center of dilation. And the most common center of dilation is the origin. Now, a special characteristic of dilations, and just from looking at a dilation, or if you want to determine if you have a dilation, is that the vertices of the figures will come together to one point. So let me just quickly show you what that might look like. So say I have this little triangle, and I were to enlarge it to a bigger triangle. And it becomes this one. Now, a characteristic of that, and I might be sloppy, so let me use a ruler, is the vertices, which are this one corresponds to this one. If I connect those, this vertice corresponds to this one. If I connect those, and if I connect this one to this one, they will all come together at one point when connected with the straight line. So let me draw that line so you can see. And I connect it here. And then this one here. So they all come together at this point here. So it looks like this vertice stretched out to here, this vertice along this line stretched here, and this vertice came along this line and stretched up into there. So that is a characteristic of a dilation. So if you ever see two images and you're curious, are they dilation? You can just sketch a line from each vertice connecting and see if it looks like they come together at a point. All right, so let's write that down, because it is important to note when you see figures whether or not, by just looking at it, if it is or is not a dilation. So lines connecting corresponding vertices meet at a point. All right, so let's look at the first example. We're going to dilate triangle ABC with a scale factor of 3. And we're going to have to graph the original image so we see what it looks like, and then our final image. Might not be big enough, but we'll see. Okay, we're good. All right, so when you do dilations, the rule is very simple. scale factor. The word factor comes from the basic knowledge of factors of numbers. So let's say I ask you for the factors of 12. You would start saying 12 and 1, 6 and 2, 4 and 3. So the word factor means a number that's being multiplied, right? So factors of 4, 2 and 2. Factors of 8, 4 and 2. So you're thinking of numbers that get multiplied. So that's a big hint, right? What do? You see the word factor, you know you're going to multiply. So that's all we're going to have to do. We're going to multiply the coordinates of the original points, of the pre-image points by 3. So let's give you the points for triangle ABC. Point A, B, C. Point A is going to be 1, 3. Point B is going to be 2, 3. And point C is going to be 2, 1. Now, the rule is you're going to multiply the x and the y coordinate by 3. So the rule is going to look like this. That's your original x and y, but you're going to multiply both of them by 3. So if you want to kind of set it up, what are these going to become? It means they're each going to get multiplied by 3, so let's set that up. And now you just got to put in your coordinates. So 3 times 1 and 3 times 3. 3 times 2 and 3 times 3. 3 times 2 and 3 times 1. And now you get your new image. A prime is going to be 3, 9. B prime is going to be 6, 9. And C prime is going to be 6 and 3. Now you could skip this step, right? You just know the factor is 3, so just go straight to this number in your head, times 3, write it down, times 3, write it down. So it is actually faster than what we wrote down, but this kind of just allows you to see what you're doing. So let's put the pre-image and the original image down, and I should have done these in red, so these will be in red. All right, so let's see. The original image will be in black. 1, 3. That's point A. 2, 3. That's point B. And 2, 1. That's point C. So this is our original image. And we are going to dilate it by a factor of 3. So it's going to look like this now. 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is my new A. B is going to be 1, 2, 3, 4, 5, 6, 9. And my new C is going to be 1, 2, 3, 4, 5, 6, 3. So, dilating by a scale factor of 3 actually magnified my triangle 3 times larger. And that's what you get when you dilate with a factor of 3. Let's look at the next example. We're going to do something a little different. Our scale factor will be a little different this time. So we're going to dilate triangle XYZ with a scale factor of 0.5 this time. So scale factor of 0.5. It is considered a number less than 1, decimal or fraction version, either way. So we're gonna have to graph this, so let's create our graph here. I'll just use the whole thing. X, Y. And our points will be X, Y, and Z. X will be -4, -6. y will be negative 4, 8, and z will be 4, 8. All right, so this is our original points. So let's put them down, see what it looks like on the graph. So negative 4, 1, 2, 3, 4. Negative 6, 1, 2, 3, 4, 5, 6. That is x. Negative 4, 8. 1, 2, 3, 4. Positive 8 up. 1, 2, 3, 4, 5, 6, 7, 8. It's very large. And 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And that's z. So this is a very large triangle. Try to see if I can. So what's going to happen to that triangle after my scale factor of 0.5? Now instead of 0.5, I'm going to use 1/2 just because I like to think of a half of something instead of 0.5 of something. And the transformation is going to be 1/2 on the x and the y coordinate. Oops. Half of x and a half of y. Sorry, I squeezed that one in there. So let's say x is going to look like let's put the 1/2 in first. 1/2 times the x and 1/2 times the y. 1/2 times the x and 1/2 times the y. 1/2 for the x and 1/2 for the y. Now we just put in our rule. Put in our coordinates actually. Times negative 4 times negative 6 times negative 4 times 8 times 4 and times 8. So what are our new image? Now instead of 1/2 times negative 4, the function of, the operation multiplication is actually, you can use the word of. So instead of what's a half times negative 4, I can ask you what's half of negative 4, and you say negative 2. What's half of negative 6? Negative 3. What's half of negative 4 again? Negative 2. What's half of 8? 4. Half of 4 is 2, and half of 8 is 4. And that's your new coordinates for your new image. And this was the pre-image. So those are our new image. Let's put them on the graph so we can see what it looks like and how this dilation affected the figure. Negative 2, 3. Negative 2, negative 3. Negative 2, 4. Positive 4. And 2, 4. So there you go. It shrunk, right? It reduced the image by a factor of half. So when you have a whole number bigger than 1, it will magnify or enlarge your image. If you have a number between 0 and 1, which is a decimal or a fraction, either one, it will shrink your image. So that's something to keep in mind. So let's write that down. Scale factors on an enlargement. The scale factor we call K. So your scale factor, if it's going to be an enlargement, is going to be greater than 1 whole. And if you have a reduction, your scale factor which again we call K, is going to be greater than 0, but also less than 1. Or you can write between 0 and 1. All right, so when you want to predict what to expect or what's going to be happening, you can already kind of have an idea just by looking at the scale factor they're asking you to apply. If it's a larger number than 1 whole, you know it's going to be larger. And if it's a number between 0 and 1, you know it's going to reduce or shrink your image. Now, how do we find the scale factor when we're given just a figure already done? All right, so let's say I have a dilation that already happened and I want to know what was the scale factor. So quickly, let me just show you. Say I have a 2 by 1 triangle. That was my pre-image. And I want to, and I actually got a larger triangle. And I want to know what was the scale factor. So if this one is my resulting triangle, you know that you're expecting a number greater than 1 as your scale factor. So you take one of the dimensions. Let's take the height. So the dimensions of your image divided by another dimension or corresponding dimension of your pre-image. And that is going to give you your scale factor. All right, so let's set up this division with the dimensions of my image. This is my image, so I'm going to refer to the height. The height of this image is 4, and that height corresponds to the height of 2 on my pre-image. And so 4 divided by 2 is 2. That is my scale factor. So that means that this original pre-image became this image by magnifying the figure 2 times larger. Say you went the other way. Say we started with the larger triangle and became smaller. That means this one would have been my pre-image, this would have been my image. So if that would have been my image, I would have started with 2 as the height of my image, and then I would have divided by 4 as the dimension height of my pre-image, and then that would have given me a scale factor of 1/2. Which makes sense, right? You start with the large one, it gets smaller, scale factor of 1/2, it got half the size. And if you started with a smaller one and it got larger, it magnified 2 times larger. So that's how you can tell what the scale factor is given a dilation that's already happened.